Welcome everyone to IASTEM conference organized by IRF Research Forum in association with a group of organizations. Talking about the organization is a decade-old organization and conducting conferences across the globe. And till now, more than 1,000 plus conferences have been conducted by the organization. And the organization has around 8 journals in the field of science, technology, management, humanities, and medical sciences. And with respect to the publication, till now more than 2 lakhs plus papers have been published, and more than 5 to 6 lakh people of people have been associated with this organization from past 12 years. So this is, about the organization in the nutshell. Without wasting much time, we'll quickly go ahead with today's presentation. We have around 15 to 16 participants for now. So each participant will give maximum of 6 to 8 minutes. We can take up the questions offline. And one unique thing is we all know research is all about collaborations and networking and all. So what we do is the organization has its own LinkedIn page. So we will be posting all today's photos, and we can tag you also over there, right? So you can share your LinkedIn profile in the chat box post after your presentation or during the presentation also. That's fine. You can keep your LinkedIn profile and share it in the group so that if anything is there, we can connect, and participants also connect with you and further discuss of any other research also, right? So these are the things. Without wasting much time, we'll go ahead now with the first participant for the day. So maximum of 8 minutes I request participants to take, and then if any questions from other participants to ask, that we can take up offline. As you guys would have already connected in LinkedIn, and also your email address and all you can share, so that if anything is there in the chat box, you can ask if there is any queries are there. So I would now go ahead with the first participant for the day. That is, yeah, first participant, Raj Kamal,
Yes, sir.
federated learning-based cyber threat detection in healthcare IoT with differential privacy. Do we have them present here?
Yes, sir. Yes, sir. I have prepared.
Yes, please go ahead.
Okay, is my PPTs available here?
Yeah, please start.
Okay. Okay. Good afternoon, everyone. Today I'll share our research on federated learning-based cyber threat detection in healthcare IoT with differential privacy. This work addressed a critical challenge like protecting patients while proving care through secure, privacy-preserving technology. Okay, the authors are, Dr. Rizwan, you are, and Dr. Subhash Chandra Patel and Dr. Sajid Ahmed. These are my co-authors, like my professors. Okay, we'll go completely to the problem statement. Okay, our problem statement, just imagine a Sarah, like a 68-year-old with a heart condition who relies on an IoT pacemaker. If cyber criminals target her hospital's network, they could potentially access her device, manipulate it, or steal her health data. And the healthcare IoT devices have revolutionized patient care, but created a new security vulnerabilities. Traditional security approaches requires centralizing and patient data, creating both prime target for attacker and potential privacy violations. Our fundamental question has now, how can we detect cyber threats without compromising patient privacy? And our approach is like our solution mirrors how medical professional collaborate, sharing insight without sharing patient files. Like we have integrated two powerful technologies. First one is federated learning, where devices can learn locally and share only insights, not data. And differential privacy, which mathematically guarantees individual information remains protected. Think of it as a hospital team meeting where everyone contributes expertise without sharing confidential reports, with added noise to further project patient identities. In a fourth slide, this is the system architect. Here, our system, each healthcare device trains its own security model using only local data. Before sharing insights, the device applies differential privacy by carefully adding nodes. These protected insights travel through secure channels or a central server, which combines them into a stronger collective model. More sensitive data receives stronger protection, just as hospital apply stricter route protocols to sensitive patient information. And this is our threat model detection. Our threat detection system works like an experienced security guard, recognizing suspicious patterns. It identified four main attack categories. First one is network-based attacks like DDoS, authentication attacks involving credential theft, data manipulating, and attacks compromising integrity and behavioral anomalies where something doesn't follow normal patterns. For example, if a patient heart monitor suddenly tries to access billing record at 3 a.m., our system immediately flags using this unusual behavior. And the experimental results. The implementation details are we have built this system using Python with a modern machine learning framework implementing DPSGD to balance learning with privacy protection. Our multi-crumb filtering identifies and excludes potential malicious model updates, protecting the entire network. Everything is optimized for resource constant device because security doesn't drain the battery of crucial medical equipment. And in the results, our results that show that ellipson value of 3.2, we have achieved 94.7 threat detection accuracy, significantly better than previous approaches. We reduced communication overhead 33%, meaning less than battery drain and bandwidth usage. Most importantly, our system provided highly resistant to sophisticated privacy attacks even when we simulated advisor trying to extract patient data from our models. They failed. Okay, in a privacy utility trade-off, this table compares different approaches. Traditional centralized ML offers high accuracy but poor privacy. In a standard federated learning improves privacy but remains vulnerable to certain attacks. Our approach strikes an optimal balance for healthcare environments, and the network attacks remain highly detectable even under strict privacy settings, crucial even they're among the most common threat. In a future work, looking ahead, we are exploring blockchain and fully decentralized application, self-adaptive models, and emerging threats, frameworks ensuring regulatory compliance, and real-time threat detection mechanism. Uh, In a conclusion, our research successfully balances privacy, security, and efficient in healthcare IoT with our system. The Sara Hospital can better protect her pacemaker without compromising her privacy. Her data stays on her device, but the inside help protect everyone. This represents an important step toward more secure healthcare technology where innovation doesn't come at the cost of privacy of security. And thank you.
Thank you, Raj Kamal, for your wonderful
Yeah,
good work. What would be the applications out of it? Where do you see this applications in?
so sir, I didn't get you. One sec.
Where you see these applications in real-time implementation?
The implementation we take the I mean the previous like data from the GitHub and from like I mean mostly I taking from GitHub only. The data is available from internet. Like we are like proving the like security and privacy is so important in healthcare also. I mean if you look, I mean how can I say, uh, your threat or I mean any opposite, I mean nature comes from to you, he want to attack you. If you have your sensitive
Report
information.
you are using SHA-256,
So sir,
the threat encryption and all using SHA-256 are basically
no, we it didn't came from the encryption still now.
okay. Uh, sure. Thank you.
Okay,
for your good work.
Um,
May the inter-
good evening, sir. Today I will present our project topic is IoT enabled solar power waste collection robot developed in our college. Our main this is our my name is Rushikesh Gavde, and these are my co-authors Kshitija Garje, Darshan Guge, and Ganesh Korwar sir. So these are the points which we will cover in this presentation, like introduction, literature review, methodology, prototype, results, and conclusion. So in the introduction, water covers over 70% of our planet, making it essential life, climate regulation and biodiversity. But in the today's world, the water pollution is the major issue. So unfortunately, it is increasingly polluted by the plastic waste or oil spills. And so and there are some conventional methods for cleanup, like often, but it involves the manual labor or expensive equipments, which are the unsafe for the people also. So here we develop our solution like a solar powered IoT enabled robot, which was a semi-autonomous or autonomous robot, which will gather the floating trash and oil spilled on the water surfaces. So these are these literature review overview about literature review. So these kind of solutions are available in the this is Rand Marine water tank. They have developed the very good design, but the expenses are more, like it is costly. So the in the methodology, what are how our robots works. So we have powered the use the rechargeable lithium ion battery, which was powered by the cell. And we use the node mcu microcontroller, which have enabled wi-fi module, and we will control the motor movements using mobile application through the wi-fi module and node mcu. So we have used the four motors, and which the movement of the motors is controlled by the motor driver. So uh, by the commands, the motion of the robot is like forward, backward, left, and right, and another separate two motors for the waste collection and water collection mechanism. So what we have done for this mechanism, we developed the conveyor belt, and another some sort of polyacrylic sponge, which will gather the oil collection. So this is a CAD model we have developed for the our robot. So we can see this is the conveyor belt, and for sponge like appearance, we have this black are the sponges, and the prototype mainly these the this roller is this function is like squeezing of the sponges, and this is the water collection tank. On the base of the tank there are small pores, like water waste collected by the conveyor belt, also oil, and oil will will from that pore and collected under this waste collection tank. So these are we have tested our robot in 2 to 3 places, like a home tub, also the nearby uh, nearby lake. So this is the one chart regarding to the moment of the robot. And this is our prototype for the robot. We have made the prototype the flowable material like foam sheet and PVC. Mm, and these are the results we have tested for the various trials. And the capacity of the our oil tank is around 50 ml, and the maximum capacity of waste is around 100 gram. So these are results, and in the conclusion, I want to say that we have developed a sustainable solution for the waste collection although this is at the prototype level, but adding some good resources and the new technologies, this could be the good solution for the for the water pollution. Yes, sir.
Well, thank you, Rishikesh. I can still see just a CAD model which has been developed, but not the implementation part. So maybe the implementation part should be worked on is what you feel.
Yes, sir.
Only CAD model you have done, not you have not implemented it still, right?
No, sir. We have developed the small prototype using foam sheet and Node MCU.
I have not
Yes.
seen that in. I couldn't able to
Yes,
see
I
that.
have added the image like on this slide, sir.
Oh,
This
okay,
is
okay.
the small prototype view of the.
It was similar to CAD model. I couldn't able to observe that properly. Okay.
Mm,
Is it working on what exactly?
yes, sir. It is working.
Okay, good. So what is the purpose of this basically for you?
So the main purpose of this the reduce the risk of the risk of the people, like they have to go in the sea and collect the water strands manually, and also this is the autonomous route which can be controlled by the and which will collect the autonomically collect the trash and oil spills.
I think wastewater collection, right?
Yes, sir.
So when you talk about wastewater collection, like what is that you have kept in like what
The
places you have
wastewater collection means the waste on the surfaces of the water bodies, like in the river or the oil spills in the seas.
okay. Uh-huh. So you are using you know uh, okay.
We are using the Node MCU microcontroller
Mm-hmm.
and the motor driver, which will control the motor movement also and conveyor belt also.
I would tried working on a simple bucket in the, a small prototype of creating this wastewater of oil spillage in a bucket and then able to
Yes, sir. We have tested in the tub, and for the trash, like thermocol and small plastic waste also we have and it
yeah,
collected by the robot.
any videos or any
No, sir. Right now I don't have any video.
okay, sure. Yeah, thank you, Rishikesh.
Thank you, sir.
Uh,
So, good afternoon, everyone. I am Prachi Sota from IT department, and today I am here to present my major project titled Paraberta: Parallel Convolution Projections of Deberta for Veracity Classification. This project focuses on building a hybrid deep learning model to detect fake news by combining global and local textual features using transformer and CNN based architecture. My work was carried out under the guidance of Professor Arun Sharma. What is fake news? Let me begin by explaining what we mean by fake news. Fake news refers to deliberately false information presented as legitimate news, often created to mislead readers for political propaganda, financial gain, or clickbait. These articles often mimic the structure and tone of real news, making them hard to identify, especially on social media where content spreads rapidly. The motivation behind this work stems from alarming rise of misinformation across digital platforms. Fake news not only misguides individuals but can also influence public opinion, elections, health decisions, and even incite violence. Detecting fake news is technically challenging because fake articles often resemble real ones in grammar, tone, and structure. Therefore, we need intelligent systems that go beyond simple keyword matching and instead understand context and language patterns deeply. The key objectives of these projects were to use Debota V3 Large, a state of the art transformer model, to understand the global contextual semantics of the news articles. Second objective was to design parallel 1D convolutional neural network CNN layers to capture local textual patterns like n-grams, bigrams, trigrams, foregrams. The third objective is to fuse the global and local features and create a robust classifier that can distinguish between fake and real news articles. I have done literature review for around 7 to 6 research papers, and the upgrades and the major updates that I think that I noticed were that many models have been proposed for fake news detection, including CNNs, RNN, LSTMs, transformer-based architectures. However, there were some gaps in the existing research. For example, the CNN LSTM hybrids often failed to capture long-range dependencies. Second gap was that transformer-only models may miss local n-gram patterns that are crucial in short deceptive sentences. The third shorting was that the most of the models do not combine both global and local feature extraction effectively. And the fourth was that there is limited work on multi-scale pattern detection, where most models lack multi-scale pattern detection for n-grams. I have used three publicly available datasets: ISOT dataset, IFND dataset, and LIAR datasets. All the three datasets are the benchmark datasets for fake news detection. ISOT dataset contains around 45K news articles, which is equally balanced between real and fake news articles. IFND dataset, it is a latest dataset over 51K records covering multiple Indian news sources like Tribune India and Augment. And the third news dataset is the LIAR dataset, which contains around 13K short statements with truth labels. It is widely used for fact checking models. These datasets offer diversity in writing styles, lengths, and publication years, helping evaluate model generalizability. So the proposed model for which I have the proposed hybrid architecture which I have proposed in my research paper is that here is Parabota. So we start by pre-processing the news headlines, where we clean text by removing punctuations, lowering case and normalizing it, tokenizing it, and doing padding and truncating. Afterwards, we input this clean data in the debugger v3 base model, which thereafter generates powerful contextual embeddings after going through 24 layers for enhancing the disentangled attention mechanism in debugger. These embeddings are then mean pooled to get fixed size vector for each headline. Next, we pass this vector through our parallel convolution block where the three CNNs, uh, which are which are of kernel sizes of 2, 3, and 4. These capture different n-gram level features from the embedding, such as bigram, trigrams, and foreground phases. After applying ReLU activation and max pooling, we concatenate the outputs to form a rich feature representation. This is followed by a fully connected dense layer and dropout to prevent overfitting, and finally a softmax layer that predicts whether the news article is true or false. We train this end to end using cross entropy loss and Atom optimizer with early stopping based on validation performance. In essence, we combine Deberta's global context understanding with CNN's local pattern detection for more accurate fake news detection. So our results are that our model Parabata has performed with 99.95% accuracy on ISOT dataset and 0.68 or 68.27% accuracy on LIAR dataset and 97.55% accuracy on IFND dataset. So to conclude, Parameter successfully addresses the limitations and previous models by fusing transform-based contextual embeddings with multi-scale CNN-based local pattern extraction. It is achieved the state-of-the-art performance, particularly on large datasets like ISOT, and demonstrated strong generalizability across others. This work reinforces the idea that hybrid architectures are highly effective in detecting fake news with improved precision. The future directions include the multimodal fake news detection, domain specific fine tuning, for example, politics, health, finance, to make it more accurate in sensitive domains. Third is adding explainable AI capabilities to make the model decisions transparent. Fourth is to create a real-time system or browser plugin for live fact checking. And fifth is supporting low resource languages and regional content through the multilingual models. So thank you very much. And with this, I end my presentation.
Well, thank you, Prachi. Very nice presentation. Good work. So using a hybrid model, you right? You I mean, I couldn't able to see the pseudocode or the algorithms you could have shown the pro the flow process of how it detects, right? And the results that could have been much more better in your presentation is what I felt.
Okay. From next time onwards, I will add it. So basically, the model works on integrating the transform-based models with the CNN layers, so that we can, cover the shortcomings of the transform-based models, which is that they lack at short distance pattern recognition. That is to be fixed by adding the CNN layers after the debota layer.
Okay, okay. Thank you. Sure. Well, I would now.
Yeah, good afternoon, sir. We are from BVRIT Narsapur, Telangana. And coming to our project title, it was automatic number plate recognition for bus arrival tracking using HAR Cascade Classifier and Tesseract OCR. Actually, we came up with this project in order to automate the vehicle entry monitoring using just a minute. Yeah, we actually came up with the project in order to automate the process of tracking the number plates of the buses that we actually do in our college premises by using manual work. So here we have used the HAR Cascade model and OCR, which was using Tesseract model. We used to extract the number plate images and the text within the number plates, and then store them in the database. So coming to this, actually the main motto behind developing the project is what we observed in our college premises is there lies a person who used to record the entry of the buses and along with the number plates. So in order to, it was actually a time consuming process, and moreover it might lead to some errors even. So in order to digitalize the process, we came up with this model where we use the HAR Cascade model and the PyTesseract model and the OCR engine, and all this combinedly they actually helps in building the model in order to gain a more accuracy even. So coming to the architecture model, there lies a camera module that captures the vehicle images, and from there we do the pre-processing. That means here the OpenCV concepts come into picture, where actually the grayscale processing, noise reduction, and more on takes place. And then coming to the OpenCV module, here the number plate detection. It means from the entire image, the number plate region will be separated, and here the HAR Cascade model, it actually talking about the working of the HAR Cascade model, it works in an rectangular patterns, where actually it scans over the entire image and finds only the text plate, and then from there the text recognition model, that is OCR, come into picture, where it extracts only the text from those images, and then it stores the data in the database, which would be helpful in further processing also. And talking about the project, it majorly divided into 5 modules, where there lies image capturing module, pre-processing module, and license plate detection module, the character recognition module, and the database management module. Talking about the image capturing module, it is the first stage where actually a camera module is being used in order to detect the vehicle images. It means the vehicles along with the number plates, they have been captured using the camera module. And then the next stage is about the pre-processing module, where actually Talking about the functions in this module, there lies image cropping, noise reduction, color correction, normalization. These are actually the grayscale conversion models, moreover, that are used in order to improve the accuracy of the model. And talking about the license plate detection model, here the number plate itself is been recognized from the entire image. And in order to detect it, we use the OCR techniques, where actually the OCR it performs the character segmentation process that actually identifies what type of character it was, and then it stores in the database that comes in the database management module. And these are our implementation results, where actually we provide where actually the camera module captures the image of the vehicles, but here we have tested it over cars, and it also worked for the buses in our college premises. And it would actually store it in the database by using the plate number, ID, and the capture date along with the time. So in conclusion, what we want to say is that here we have used the R cascade model. So you might also ask that there might be other additional more improved models, such as deep learning models such as YOLO V8 and many other. So why we have gone for this model is that for the resource constraint and for its easy implementation. And since we have already thought of making it in a prototype and testing purpose, so that we gone with this model. And even with this model, we have gained a good accuracy, so that for the future enhancements, we have included using the models like YOLO V8 and some other additional models. So yeah, with this, I conclude my presentation.
Well, thank you for your presentation, Harshvardhan Reddy. Good work. Please share your LinkedIn profile details, and participants, if they have any queries, they can get in touch with you in the chat box. Thank you.
Yeah, okay. So I have just a small query. Actually, we are asked to share our PPT with the presentation coordinator. Do you want to share it in the chat
No,
box?
you can just no, coordinate with the email with the coordinator, not an issue.
Okay, so okay, fine.
Thanks.
A very good afternoon, everyone. So, project is like GPS-based automatic speed e-challenge generation as per the speed limit. So, we have seen this problem in a hackathon, and from there we have got an idea to make this project. So, all of us, almost all of us, have traveled on the highway, right? But have you ever seen those speed guns or speed radar bars which calculate the speed? Those speed guns and speed bars are actually used to generate challenge for overspeeding. But if you think from the perspective of the policemen, traffic policemen who are trying to caught the ones who overspeed, it's very hard for them because it is very limited to a particular place and it requires sometimes a manual effort. And mostly in the cities, it's totally manual. But on the highways, it's very limited to a particular position. So me and my friends, my team members, have came with a solution with a device which will be integrated in the person's car, into an individual's car, or any other transport vehicle like a truck or a bus. So what this device do? So we have integrated a GPS and GSM module in this device. With the help of this device, the device will monitor the speed in the real time, calculate the speed with the set limit, or like calculate the speed in the real time, and it will check with the set limit for this particular route. So, for example, there is a highway where the speed limit is set to 50 kilometers or 60 kilometers. And in the real time, our device contains the data of that particular route, that in this particular location, this this road contains a speed limit of 60 kilometers. And while driving, the system continuously real time uh, checks like if the vehicle is overspeeding or not. And if the vehicle overspeeds, for example, for 10 seconds, it will be like, okay, warning, overspeeding, warning. But after 10 seconds, it will generate a challenge to the user who is registered in that device. And then if this data will also be sent to the server of the traffic police management or any authority who uses this system. Like, for example, if the schools use this system for tracking the drivers driver's activity while driving school buses, any other authority. But let's take an example of the traffic policeman for now. So it will generate a challenge to the person, and then it will send this data to the server of traffic police authority. This will make the system more more precise, having the data, and there are more and there is no need of more manual work. So this will automate the challenge system. It will it will be bring more integrity to the system also, and that people might not question again that why we have got the challenge now, because they themselves have seen there's a record of it. So this will be useful for the traffic policemen and also any other authority like schools, or like office cabs, to monitor if really the people there are driving safe or not. So we have used uh, we have used the hardware like Arduino Uno, GPS and GSM modules, LCD, I square LCD, and basically this was on I square LCDs, antennas. Yeah, that's all. That's a brief about the technologies we use, and we use embedded C language to dump the code. So if we take the scenario board to the next slide, coming to the literature review, we have read 10 to 12 papers, but we have selected 3 to 4 papers. And mostly in these papers, we have seen that there was a gap of real time. And also, not about the real time, but it was also that they were not able to upload data to the cloud, means basically the server. So we added this feature of uploading data to the server in real time, and mostly these papers use like the capturing photos and then using machine learning algorithms and deep learning algorithms to understand the number of plates, or like uh, using notification system like emails. But we have used the real-time system using the GPS and GSM modules, and then we integrated it with the server. So like this challenge is sent to the person, and this data is entered to the cloud. So if yeah, so as I told, the problem statement is that there are very limitations, and like we have tried to to overcome these limitations for people. And yeah, come to the next part. Next slide, please. Yeah. So this is a flow chart I want to explain to everyone. So imagine the vehicle starts, okay, and then the GPS module is on. So it gets your location by using the longitude and latitude. Fine. And the sensors there continuous vehicle start you're driving. The sensors are continuously tracking your location, and they're continuously using those longitude and latitude to track your speed. So so if the speed limit is set for, let's take that the speed limit is set for 45 kilometers per hour. Okay, so you're driving at 20. There is nothing. There is just written on the screen that system is running, and yeah, just we can go back. I'm explaining the flow chart. Flow chart, please. Okay, Ankush, show the flow chart. Okay. Uh, so talking about the let's go now. I think there's a communication gap between me and the team member, but it's fine. The flow chart is like, the vehicle is started. It is on the 20 kilometer per hour speed. The system shows it's running. The system is running, but after some time, when the driver starts to overspeed the vehicle by 46 kilometer per hour or 47 kilometer per hour, for the 10 seconds we'll get a notification but after those 10 seconds, the he will generate a chala will be generated. Uh, after like in this meantime, this GPS is completely is continuously actually comparing your speed limits to the set speed limit, and once the speed limit is over the speed limit, the message is sent to the person, and then the challenge is issued, and then yeah, this data is also sent to the server, and the message is sent to the owner. That's the working of a project, and that's a full stop. Yeah. To the conclusion, we have came. Ankush, can you show the conclusion part? Okay. So propose. Yeah. So the conclusion is that the system has elevated challenges favor traffic policemen by enabling remote monitors of the highway. Thus reduces physical presence and allowing safety also, as like there may be there may be certain accidents where the policemen will actually get hurt. So using the system, we can actually in the real time monitor the speed. This will lead to more precision and more safety for our traffic policemen. Also, the automation will help in this really fast forwarding world that there is more and more lesser and lesser manual work, and this will also reduce in the rash driving cases. So in the end, I would like to say that this project only not only promises to enhance road safety and affecting efficiency, but also contributes to a more effective and practical use. So these are the references we have used,
Um, Nice to see
and
the
this is the hardware.
efforts which you have put, especially on prototyping the model. Good work, nice efforts. Please share your details in the LinkedIn. Participants can get in touch with you, and also email ID. We can take up the questions offline. Nice efforts. Thank you.
Thank
Uh,
you, sir.
yep, we can take up the questions
So
off.
so on LinkedIn, like what we have to uh,
Hmm,
this is the server report,
sure. Okay.
and this is like this message is sent to the person about information telling that on this particular position the challenge got issued.
Good one. Good work. Thank you, Sachit.
Yeah,
Nice. Okay. It is
thank you, sir.
autonomous, completely
Uh,
automated.
yes, sir. Computer science.
Okay. Okay. So it
Thank you, sir.
usually it will be in a single place. One should carry it,
So this system will be in a single place. Not a single place. This system will be integrated in a
or fixing
person's
it in
vehicle.
one place.
Yeah, fixing it in one place in some way in the car, and then linking it with the driver's number or like the authority's number,
Mm, 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 mm. Okay,
so
okay.
can they can get the challenge.
Good one.
Yeah,
Thank
that's it. Thank you, sir.
So, good afternoon, everyone present here. I am presenting today's major project of finally, that is hand gesture based PPT controller. Uh, these are my group members and co-authors, and we had done this. Dipanshu, Grishma, and Akash, and we had done this project under the guidance of Professor Dr. M.G. Panjwani sir. So yeah, let's begin with it. So the basic introduction I would like to, like, what is the basic root of a project is, as we know, presentations, like it can be seen, presentations are the staple in educational and professional settings, whether that be the corporate or education sector or any sector. Presentations have become a convenient and a reliable way for make make the stakeholders understand what you're trying to explain or what you're trying to present. So as we know, in every case for presenting today, we have presented pointers and as well as presenting remote.
but the main question arises that we are dependent upon particular device or particular physical interaction device that we have come across. So then we have come across that problem statement that like traditional methods of controlling PowerPoint presentations use keyboards or remote controls. So like it can limit the presentator's mobility, it can limit its action, and it can limit its particular workflow or the way he wants to do. So these methods, even as it can be seen, the methods often disrupt the flow of presentation, and it hinder audience engagement for various numerous circumstances that can be caused due to particular dependability issues. So we need a more intuitive and hands-free solution for to be presented, as it is one of the basic necessity for every sector of every stakeholder. So this is the proposed system, that is hand gesture based PPT controller. We would see how the whole devices look in the conclusion part. So our system consists of an embedded hardware module, which is integrated with Arduino Uno microcontroller, and we are using hand gesture
What
sensors.
slides are not moving. I can still see the first slide. I think we
Uh,
can exit the full screen and then go back to
okay,
normal.
okay, just a second. So now is it the like next slide visible?
Yes.
Yeah. So basically, what we have done is we have used an Arduino Uno microcontroller in our hardware module, and for capturing the gesture, what our project does is it captures your hand gesture, which are like it can be a left gesture or right gesture or a up gesture or a down gesture, and according to it, we have accountability for particular actions performed, that for a left gesture or for the right gesture what particular action must be performed on the computer end. So that hand gesture is been captured by PAJ 7620 hand gesture sensors, and for transmitting that particular gesture and what actions should be performed, that signal must be transferred through our HC05 Bluetooth module at the computer end. So as it can be seen, the PAJ 7620 gesture sensors like detect specific hand gestures, which can be seen in following points, and this hand gesture is basically processed by this particular hand gesture is processed by the Arduino Uno, and it is transmitted via Bluetooth module. uh, so what main objective of our this proposed system is to build a gesture recognition system that uses natural hand gestures to control a PowerPoint presentation, and it can even, for now, as of now, we are also added for the up and down gesture to control the volume and volume up and volume down. So this project will be helpful in overcoming various drawbacks of traditional method of human computer interaction. Obviously these projects cannot be up to the extent of PowerPoint presentation. On future scope and on above more advancement, we can also do it for various computer basic applications. For example, opening we can set up particular macros, individual macros for a particular issue. It should open camera app, or it should open particular browser, so we can customize it accordingly. None the fact that that is the future scope for it, but I'm just stating that it could be a major future scope as well. We could also do home automation in it, and the main is the disabled people and amputees find it difficult to interact using traditional human computer, and it would be convenient for them to operate PPTs and other applications to this device. So this is our hardware design, and as I have explained this already earlier. So the main signal processing and communication is done to a Arduino Uno microcontroller, and for at the computer end, the we have used a .NET .NET programming language to interact and integrate with the Arduino Uno. So for particular gesture, what action must be performed, we have developed it using .NET. So these are our hardware and software requirements. For hardware, we have Arduino Uno microcontroller. Uh, for gesture sensor, we have PAJ 7620 gesture sensor, and for Bluetooth model we have HC05 sensor, and this entire hardware is powered by a 9-volt battery, so that it is for as of now it is not rechargeable, but we can replace it with the rechargeable battery if we need to, as we have developed only prototype, so we have used 9-volt battery. And on software end, we have Arduino Uno IDE for all the codes and the actions it must be performed for particular things and particular signal. And we have your ASP.NET for all the coding and implementation part. So let's now begin towards the construction, design and workflow, how exactly the workflow begins and ends with it. So if there is a hand gesture, it first detects the gesture, whether that be left, right, up or down. This gesture sensor captures particular hand gestures, and this gesture is processed by Arduino Uno microcontroller, which is which has power supply in it, and this microcontroller sends particular signals to its Bluetooth sensor HL05 module. These signals are being transmitted to this particular sensor, and these signals are being received by a computer sub BT end, and on that end the particular software application which are developed using ASP.NET is being processed. It processes the particular signal, and it performs particular action on the PPTs or any other application. So binding it towards the conclusion, this is how our device look. This is just a prototype for it. So just to be at a glance, the hand gesture based PPT controller represents a significant advancement in presentation technology. Obviously, as I mentioned earlier, it cannot be just for use for the extent of PPT presentation. It can be also used for various computer application, and in more advancement, we can also customize it according to our head and according to our convenience for particular things. Yeah, so this is it, sir. Hello.
Well, nice work, Harsh.
Yes, sir.
So, is this working now? The hand gesture thing?
Yeah, sir.
What
It
the
works
slides
now.
now?
Yeah,
It's
yeah.
going. Okay, it's working. Is there any hand gesture video or photos kind of it like it changing and that's moving or something?
Yes, sir. Basically, as it can be seen like in the PPT screen, there is a small LCD display attached to it. So the particular hand gesture you perform, it shows the direction for your hand gesture. For if I have moved the left, then it will show the left arrow. If I have moved hand gesture towards
Okay,
right,
the
it will show.
arrow it shows.
Yeah,
Okay,
yeah.
good, good. Okay, thank you, Harsh.
Okay.
Good presentation. We can connect and we'll see. Share a LinkedIn profile.
Sure,
We
sir.
can connect.
Okay.
Together. Thank you.
Thanks.
So imagine this situation where it's a busy Monday morning and you have gone out to work to meet a client for a high stake contract renewal. But despite reaching early to the meeting center, you are faced with a new challenge, the challenge of finding a parking spot. You circle the area desperately, unable to find a spot. Finally, when you do find a spot, it is 2 kilometers away. And by the time you park and you walk from that area to the meeting place, it is already 35 minutes late. The deal at the risk. This must be familiar to those living in Bangalore, right? The traffic we completely know about. And that is where Partly steps in. Partly is an innovative solution to eliminate parking hassles developed by a passionate group consisting of Ankana Chakraborty, Momita Shri, Aishwarya Roy, Tony Shaha, and Rima Bachar under the guidance of Dr. Shoma Dotto. Partly is your smart parking assistant designed to save your time, reduce your stress, and keep you ahead of the clock. In a world which we are living in, we see that there has been a skyrocket in the number of vehicles which are owned by people, and parking spot finding still remains a problem. Partly bridges this gap because most of the time it's not that there is a lack of space, but it is the lack of knowledge about the availability of space which creates the problem. So that is where we come in. We have seen that there has been a recent study by the government of Shillong where they said that though there has been spaces available for parking, but the lack of knowledge about the availability of those spaces has become a problem, which has led to a demand and supply misbalance. So this is where a problem statement is, because the disconnected and outdated parking systems contribute to urban traffic congestion and driver frustration. And we have proposed a smart car parking management system integrating with mobile applications, real-time data, and centralized web services to locate nearby available parking spots instantly, enable pre-booking and digital payment for parking, providing real-time updates and manual override options for booking. And this project aims at reducing congestions, optimizing parking space usage, and enhancing user convenience through seamless technology-driven parking solution. So we have seen that though there has been previous implementations for this smart parking management system, but majority of those are based on hardware solutions. So we have come up with a solution which will be cost effective and efficient as well. So we have seen the IEEE wireless sensor, and the reliable level of performance is somewhat gets affected because of the environmental conditions such as weather and other wireless networks. And there's morphological processing with the accuracy level is low. And then the CCTV cameras require the parking lots to be free and limited by image quality and perspective distortions. So the technology we have used is Flutter because it is sleek cross-platform application that works seamlessly on Android, iOS, as well as the web. So whether you're headed at work or a client meeting or just out for dinner, everything works over here. And then we have used Firebase for the user authentication and the login database. And we have used the Google Maps API with places, maps for Android and iOS. And there has been other dependencies of Flutter packages where we have the geolocator for finding the nearby location so that they can get the parking places available at that instant or at that place where they are located at. And these other. Okay, so the system functionality goes as we are starting, the user needs to log in or create an account. Then it is divided into two parts, the parking providers part and the user who will be using it. So let us start with the parking providers side. So they need to log in with the names, their password, their phone number, as well as their email for authentication. For giving out a place for parking, they need to have some government credentials as well. That needs to also be provided to them, which will be checked in the backend system using OCR and manual verification, and then only they will be able to sign into their account. So after successful verification, they will be allowed to give the area for which they have been going, like giving the spot details, like number of places, like the number of spaces which are available, the exact location with the address where it is available, and they're taken to the dashboard. Now coming to the user side, the user needs to log in with their name, their password, their driving license number, which again will be verified using OCR and the regex formula, and their phone number. So once they're giving these, a verification email would be sent to their email ID. On clicking it, they will be successfully verified. And then they will be allowed to search parking spots in two ways. The first one would be they can search in nearby locations that they are present. And the second is that they can pre-book at a stipulated or at a given particular place. And over there, they would be seeing if the slot is available or not after selecting their place. So of selecting the place, we have using the Haversine formula for calculating the nearby distances. And over there, once they have been choosing their spot, that spot is booked for them for that particular point of time. Now, they will be giving their vehicle type, their vehicle numbers, and after booking confirmation, after successfully confirming and as well as paying, they would be given a QR which is generated to them. So once the QR has been generated on the parking provider side, it will be showing on the dashboard that the particular person has booked your space at this particular time from this to this. And once the user reaches the particular space, they need to scan their QR code, and from there, the timing will be starting. And for extra time, if they have taken, then there will be internal uh, cost cut from their side and given to the provider as well. And they can also, if suppose a particular emergency has come and they are not able to like go to that particular time, they can as well as cancel the booking within say 15 minutes, and they will be getting the complete refund. So we have the registration and login processes, then the selection of parking location, selection of vehicle type, payment using online methods, and generation of QR for validate successful booking. To summarize everything, so this is where the app flow comes in, a visual representation of our application. uh, and the future prospect is that we have been based on metrics such as nearest available parking spot, booking hours, spot charges. We would be suggesting the best places as well as using Dijkstra's algorithm to show which place they will be reaching at an earlier place. Say even if a particular place is say for at a distance of say 200 meters, but the traffic congestion is too high, but a place which is say at a distance of 800 meters will be reached further. So giving smart enhancement on this, and as well as introduction of nearest petrol pump location, garages, which will be verified, and car maintenance reminder systems. And we are planning on expanding it in cross country variants. So basically, partly is a hybrid car parking system which combines both manual processes and automated updates and bridges users, parking providers, and parking facilities for hassle-free urban commuting and parking. With the addition of parking space availability, manual payment options, and automated updates, it is like it's a very user-friendly experience which will be happening, because our system connects three entities: the user, the parking spot providers, and the payment gateway. And the entire interaction is done in a very streamlined manner, as well as you get an encrypted manner as well. In the backend, we have used Firebase, and with Firebase, we have the SHA-256 ingrained, so that whatever data you're uploading, whatever it is, it stays protected. Because we are living in a secure, like a digital world where security is a very important feature at this point of time. So, well, in conclusion, partly simplifies your parking bridge by bridging technology, convenience, and real-time data. And our hybrid system provides immense value because it has the potential to transform your everyday commuting, making your life a little bit easier. Thank you so much. Hello.
So nice to see the presentation by your team. It was a good topic which you guys have done. So implementation, have you worked on it?
Yes, sir.
Okay. Any case studies?
So for the case studies, we have been doing a lot of research works. The most important one which we found was that done by the government of Shillong. There was a paper published which like by the government of Shillong, which said that they have a lot of like the number of vehicles is skyrocketing, and there has been a less number of parking spaces. Though some people want to give out their parking spaces, the users don't have knowledge where they are and how to locate them.
Okay, okay. Mm-hmm. Good work, ma'am. Thank you.
Thank you so
Please
much.
share your details, like connect